Hey, what's up guys? My name is the Cherno and welcome back to my C++ series. Today, we're going to be talking about references. Last week we talked about pointers, so if you didn't see that video, you are 100% going to have to, because references are really just an extension of pointers, so you need to be able to understand, at least at a basic level, how pointers work in order to actually get this video. So go ahead, there'll be a link in the description below. If you haven't seen the pointers video, definitely watch that. Okay, so pointers and references are two kind of keywords that are tossed around a lot in C++ and other languages. They're essentially the same thing though. I just want to start this video by saying that pointers and references are pretty much the same thing as far as what the computer will actually do with them. Now, semantically, so how we actually use them and how we write them, there are some subtle differences. But at the end of the day, references are just pointers, usually, in disguise. That's just all they are. It's just syntax sugar on top of pointers to make it a little bit easier to read and a little bit easier to follow. A reference is essentially exactly what it sounds like. It's a way for us to reference an existing variable. Unlike a pointer where you could create a new pointer variable and then set it equal to null pointer or something like that, set it equal to 0, you can't do that with references because references have to reference an already existing variable. References themselves are not new variables. They don't really occupy memory. They don't really have storage. They're not like your typical variable, because what they are instead is a reference to a variable. I'm going to be bringing up a few different examples in this video. However, I'm going to keep it brief because references aren't that complicated, and the best way really to learn how to use them is actually to start using them. So as the series goes on, we'll be using them all the time, and you'll see what kind of the best practice is, or at least my opinion on what the best practice is to do with references. However, if we jump into some code, let's say that I make a variable. I'll call it a and I'll set it equal to 5. It's just going to be an integer. If I want to create a reference to that variable, I can do so by typing in the type of the variable, followed by an ampersand. Note here that the ampersand is actually part of the variable declaration. In the previous video about pointers, we learned that if we create a pointer, we can use the ampersand operator here to actually take the memory address of an existing variable. It's different here because the ampersand is actually part of the type. It's not, you can see it's not actually next to an existing variable. It's part of the type, so just note that difference, because with a lot of people, as soon as you see an ampersand, they think, oh, it's a reference, or oh, it's definitely an address of. It's kind of depending on context here. So in this case, because it's next to the type, it's a reference. So if we keep writing this, I'll call this ref and I'll set this equal to a, and that's really all you have to do. There's no kind of weird operator or something that we have to use here. We just set it equal to an existing variable. And so what we've done now is we've essentially created something called an alias. Because this ref variable, I say variable in quotes here because it's not really a variable, it's just a reference. Like, this ref variable doesn't actually exist, it just exists in our source code. If you compile this code right now, you're not going to get two variables created, a and ref. You're just going to have a. What we can do now is we can use ref as if it was a. So if we set ref now equal to 2 and then print a, if we run our program here, you're going to see that a is equal to 2 now, because we're printing a and we've just changed ref to 2. Because for all intents and purposes, ref is a. We've just created an alias for a. And in this case, our reference isn't a pointer or anything like that. There's no need for the compiler to actually create a new variable. If you compile this code, it's just going to act as if we just set a to 2, because that's really what we did. This is just something that we can write in our source code to make our lives easier if we wish to alias a variable. Now let's try something a little bit more complicated. Suppose that we wanted to write a function which was supposed to increment an integer. If we just write the function like this, and then do something like value plus plus, what will actually happen is if I create my integer over here, and then I call increment with a as the parameter, what's going to happen here is, since we are just passing this by value, you can see that we're not passing this as a pointer or as a reference or anything like that. It's actually going to copy this value 5 into this function. Just copy it. It's going to create a brand new variable called value with that. So it's almost as if we were to write something like that. That's exactly what will happen. So instead of that, and I can prove it of course if I just run my code here, and we log this, we're actually going to still end up with 5 printing to the console, which you can see over here. What I need to do is I actually need to pass this variable by reference in order for it to increment, because what I really want to do is I want to actually affect this variable here. So how can I achieve that? How can I actually modify this variable by passing it into a function? Now, last time we talked about pointers, and remember, pointers are memory addresses. So theoretically, I hope you're putting this together in your mind because it's so exciting, but theoretically, what we could do if we were really clever, right, right, is we could, instead of passing the actual value 5 into that function, we could pass the memory address of this a variable. Because then what we can do in that function is we can look up that memory address, see that value 5, and then just modify that memory address. We can write to that memory address since we've passed that memory address into the function. So let's give that a shot. What I'll do is I'll modify this to actually take in a pointer, and I'll still call it value. And then what I'll do here in increment is I'll pass the memory address of a. Instead of just the value 5, it's now passing the memory address of this variable. One more thing I'll have to do is actually dereference this value so that we can actually write to that memory instead of modifying the pointer itself. If I just do this without the dereference, it's going to just increment that address, right? So pointer, of course, just a memory address, just an integer. And if I do value plus plus without the asterisk, without the dereference operator, then it is just going to increment my memory address, not the actual value there. Now, because of the order of operations, it's actually going to do the increment first and then dereference. So what I want to do instead is dereference first and then increment, because I don't want to increment the pointer and then dereference it. I want to dereference the pointer first and then increment the value at the pointer. So if I compile this code and run it, you will see that I will get the value 6 printing. So awesome, we've successfully managed to pass a variable by reference into a function. However, this video is about references, so we can do exactly what we just did here a lot easier with less code and with less kind of decorating our syntax if we just use a reference. And that's what I would do in this situation. I would use a reference. So what we can do is rewrite this to take in a reference instead of a pointer. And then what that means is that I lose this whole need of dereferencing. I can change this back to exactly what it was. And then over here, I don't need to pass the memory address of a, I can just pass in a. And since it is being passed by reference, we've basically rewritten the code to do exactly the same thing. Internally, when it gets compiled, it will be exactly the same as what we've written before. However, this time, it just looks nicer in our source code. Again, that's the only difference. If I run my program, you can see we get 6. So that is all that references really are. They are just syntax sugar. References, there is nothing you can do with a reference that you cannot do with a pointer. Pointers are like references, except they're even more useful and they're even more powerful. However, if you can get away with using a reference like what we just did here, absolutely use a reference because it's going to be a lot cleaner and simpler to read. Not that pointers are really difficult to read, but it will look a lot cleaner in your source code. One other important thing that I want to mention with references is that once you declare a reference, you cannot change what it references. What I mean by that is that suppose that I had 2 integers. I had a and b was set to 8, a was set to 5. And then what I wanted to do is declare a reference that was set to a, and then maybe later on in my code, I decided, oh, actually, you know what? I want to set my reference to be referencing b. Can I do something like that? The answer is no, you can't do that. What will happen in this case is that it will effectively create a reference to a, and then when you decide to set that reference equal to b, it will just set a equal to the value of b, which is 8. So what you will end up with here is a being equal to 8 and b being equal to 8. That's it. That's what you'll get. And of course, because of that, that also means that when you declare a reference, you need to actually assign it to something. You cannot just do this. You can see that the compiler will not let you do that. It requires an initializer. When you declare a reference, you have to immediately assign it to something because it has to reference something. Because remember, it's not really a real variable, it's a reference. So in this example specifically, what would I do if I actually wanted this kind of functionality? If I wanted to actually change what ref was a reference of? Well, of course, as I mentioned earlier, this isn't a real variable. We would need to create some kind of variable of sorts that we could set up to point to a first, and then later on we could switch it to point to b. And of course, I keep saying the word point in the hopes that you'll understand that I'm talking about a pointer. So instead of this, let's just make this a pointer. We can initially set it to the memory address of a, and then when I wanted to switch to it being pointing to b, I can just switch it like this. Because remember, to actually start affecting the value that this pointer is pointing to, I need to dereference the pointer first and then set it equal to something like this. So in this case, I'm setting a equal to 2, and in this case, I'm setting b equal to 1. And if I was to log both of these, they should be 2 and 1. And you can see that they are. All right, that's pretty much all I want to say. Really simple stuff. We'll be using references a lot more in the future. Again, they're one of those things that you just use all the time, like pointers. So you'll see a lot more examples down the road as this series progresses. If you enjoyed this video, please hit the like button. You can follow me on Twitter and Instagram. And of course, if you really enjoyed this video, you can support me on Patreon to make sure that I can continue these C++ series videos and make more awesome videos in the future. All right, next time we're gonna kick it up a notch. I'll see you guys later. Goodbye.